right, let's look at how a titration problem works. So here's a good example. We're going to stick right now with acids and bases because they are easier to deal with anything that makes a precipitate. We'll get to that later. So I've got this example. It takes 25 milliliters, which is a volume, of a 0.050 mole per liter, which is concentration, solution of hydrochloric acid to neutralize 345 milliliters, that's another volume, of sodium hydroxide solution. What is the concentration of my sodium hydroxide? Well, since I know the concentration of my hydrochloric acid, that is going to be my titrant. So my titrant is HCl, and I know a concentration, a volume, and we can get from that the number of moles. So for concentration, I got 0.050, big capital N for moles per liter. I got to change that volume to liters by moving that decimal 3 places over to the left, so 0.025 liters of HCl. And then for my NaOH, that's going to be my analyte because I don't know the concentration. So I got concentration, which I'm looking to find, a volume I know of 1, 2, 3 places over to the left, so 0.345 liters of NaOH, and I'm looking for a number of moles. So I know when I've got an acid-base reaction and the acid only has one hydrogen, we call that a monoprotic acid-base reaction. So I'm going to write the reaction up here. Hydrochloric acid added to your base. Basically what happens is the acid is neutralized by the base, and you've got these ions that switch places with each other. So you end up getting salt, NaCl, and you end up getting H2O or water. And I check to make sure my equation is balanced. I've got one H or two H's. I got two H's here. I got one Cl. I got one Cl. I got one Na. I got one Na. So my stoichiometric ratio of hydrochloric acid to NaOH is 1:1, which means however many moles of HCl I have is how many moles of NaOH that I neutralized. So I look here, I have a concentration and a volume. So to get the number of moles, I can multiply concentration times volume, which is going to be the 0.050 times the 0.025. So grabbing my calculator here, my number of moles is going to be 0.050 times 0.025. So I would have, with correct sig figs, used up 0.0013 moles of HCl, which means that since this is a 1:1 ratio, that means I neutralized 0.0013 moles of NaOH. And now we're already to the last step. I can figure out what my initial concentration was with my NaOH because concentration is moles divided by volume, which is going to be the 0.0013 divided by the 0.345. And so my initial concentration of my NaOH was, wait for it, with correct sig figs, 0.0038 moles per cubic decimeter, or big capital M for molarity, or moles over liters, whichever you prefer. So basically the steps are to figure out how many moles of the titrant I used, check that with the stoichiometric ratio to see how many moles of the analyte were neutralized, divide the number of moles of analyte neutralized by the volume to get the new concentration. And that's how we figure out the initial concentration if your analyte is NaOH.